We are looking at lesson 50 today. 50. Right? And in this lesson, we're going to learn to graph inequalities. This is not new. We're going to learn to write inequalities from a graph. And I'm adding something to the lesson that's not in the textbook. We are going to learn to write inequalities this is new, in or using interval notation. Okay? This is an honors kind of a topic thing. It's not difficult. It's just another way that you learn to read mathematics. Interval notation is going to be something that you'll see for the first time in Algebra 2, and then you'll see it a lot more in the classes beyond Algebra 2, or you should. All right, so interval notation is another way of writing inequalities. Okay? All right, so just kind of we'll talk about that as it comes up in just a minute. But today we're graphing inequalities, and that's going to be graphing on a number line. Again, you've done this already. It's very simple, so it's a good opportunity for us to throw things a little bit deeper. Now, just some background work. The solution of an inequality is one variable is a value or set of values that satisfies the inequality. All right? To determine if a value is a solution to an inequality, we do exactly what we would do with an equation. We substitute the value of the variable into the inequality or equation, and we simplify. If the statement is true, the value is part of the solution set. If the statement is false, then the value is not part of the solution set. All right, so, but with inequalities, instead of looking for equality, we're looking for just a truth value of the statement. So if we're checking an inequality and we ended up getting a statement like 6 is less than 8, then we could conclude that whatever value we put in there resulted in what kind of statement? What kind of statement is 6 is less than 8? It's a true statement, and so that value would be a solution. If we substituted a value into an inequality statement and we ended up getting something like 6 is greater than 8, then we're going to do what? We're going to reject that value as a solution because it results in a statement that is false. Is 6 greater than 8? No. So that particular thing wouldn't be a solution. Okay, if we were checking it. All right, so let's just kind of dive in and look at things. Determine which of the values, 0, 2, 4, or 6, are part of the solution set of this inequality. All right, now I want us to come up with two ways to do this. Griffin? You could solve the inequality, right? You could solve the inequality and see which ones work. Tell me what we would do to solve this inequality.
You'd
add 5 to both sides, right? Then divide both sides by 4. We get 4y is greater than or equal to 16. So only values that are greater than or equal to 4 are going to be solutions, right? Okay, so that means 4 and 6 would be solutions from that set. Yes. All right, what's another way we could approach this problem? We could substitute the values into the equation. We can put 0 in. Is 4 times 0 minus 5 greater than or equal to 11? No. That's false. Is 4 times 2 minus 5 greater than or equal to 11? That's 8 minus 5. That's 3. 3 is not greater than or equal to 11. That's false. Is 4 times 4 minus 5 greater than or equal to 11? Yes. So 4 is a solution. And you could do it that way. So we can confirm that they're solutions, or we can solve the equation and go. Now, it does not tell you what method to use here, does it? Okay, so we can use whatever method we would like to accomplish our stated purpose. All right. Now, inequalities. It's not always reasonable to list all values of a solution set, right? What do we mean by that? What does this mean by this? If you're reading this in a textbook, you're sitting at home, you're trying to learn this yourself, what does that mean, Josh?
That means that, like, for solutions of that, you gotta say x is greater than 0.
Like this one here, for example, x is greater than 0.
That means you have to list all.
Could you list all the solutions to that? No, because what kind of a set is it? It's an infinite set, right? It's definitely, there's an infinite number of things in that set. All values, all real values greater than 0. That's all rational numbers greater than 0, all irrational numbers greater than 0, all numbers greater than 0. It's not a listable set. Okay, so we can choose to show our solutions on a number line, right? That's another way we can represent our solutions. And we're used to doing that, right? What do we talk about in lesson, I don't know, what is it, 47 or 49? 49, when we were graphing things. What did we say that the graph of like y equals 2x plus 5 is? What is the graph of y equals 2x plus 5? It's a line, right? What is that line? It's the infinite set of all the points that make this equation true, right? Yeah. It's the set of all points that make that equation true. So graphing, seeing graphical representations of our solutions, Griffin, seeing graphical representations of our solutions, not something that's unusual to us. Okay? I got you, Karis. All right. All right, now, so we can express the solutions of inequalities as number lines, and you already know how to do this, right? Greater than or less than, what kind of circle do we use on the number line? Open circle.
Open.
Greater than or equal to, less than or equal to uses a closed circle. Okay? So now, let's just take a minute right now to learn this new thing that I was telling you that I wanted you to learn. I want you to, and you're going to need to write this down, it's new. I want you to learn interval notation. And we're not going to do this a lot this year, but I'll mention it from time to time just to kind of freshen it up in your mind so that you have some preparedness for it when you see it first in Algebra 2. It's not difficult. It's just another way of writing inequalities. All right? Now, first of all, let's talk a little bit about some set language. Okay? We know what sets are, right? We just looked at a set just a moment ago. 0, 2, 4, and 6. It's just a group of, it's a collection. In mathematics, the definition of a set is a collection of objects or things. I mean, it doesn't have to be numbers. It could be variables. It could be functions. All right? So it's a collection of things. Each thing in the set is called an element of the set. All right, so when you get into upper level mathematics, you might be talking about a set of functions, or you might be talking about a set of numbers that have a specific quality or characteristic. All right, numbers that divide 5 evenly, or numbers that are divisible by 5. So how would you say x is an element of that set? Yeah, Griffin? It's kind of a trick question. You would say x is an element of that set. How would you write x as an element of this set?
You don't write it. Not a trick question.
No, it's not another trick question. So what I want you to do here, if I wanted to define, now listen, if I wanted to define that x is an element of this set, I would use this symbol. X is an element of this set. Okay? So this symbol, and all I'm teaching at this point is that this symbol reads is an element of.
Oh.
All right? So it's set notation, right? You guys have learned some set notation. Those of you who've been to some math competitions, you've seen some set notation. You may not have recognized it. Here's a set notation. That's a set notation. This is set notation. This is set notation. This is set notation. So you've got to kind of learn to, we'll learn most of these symbols through the course of this year, but X is an element of this set is how you would read that. What that means is X can be any of those things. All right? Now, interval notation has these rules. Let me erase some stuff here. Here's the rules for interval notation. All right? Intervals must be ordered. Okay, what do we mean by ordered?
It must be sequential.
In numerical order, right? So from left to right, if you're reading an interval, it must read, back that up, it must read from smallest value to largest value. All right, so it must be ordered. Then you don't even know what an interval looks like at this point, but that's pretty easy to understand, right? Okay, here's another one. All right, greater than or equal to, less than or equal to symbols. And when we're graphing those, they get closed circles, right? Okay. These symbols get the bracket. Okay. Bracket, a hard bracket. And that, no, you can kind of put that in quote. Trust me, this seems kind of complicated at this point, but when we put it all together in just a minute, it's going to be easy. So if that's a symbol for less than or equal to, greater than or equal to, we need a symbol for what? Just less than, greater than. All right, so less than, greater than, and we're going to add something to this. And the infinity symbol, we're going to be using some infinity symbols, get parentheses.
Write an 8.
It's, the lazy 8, always just two little zeros beside each other. All right, so these get either parentheses this way or parentheses this way. And we'll talk about what that means in just a second. That's it. That's all the rules for interval notation. That's all the rules for interval notation. Okay?
Your head was just coming in.
Okay.
You saying I have a large head?
No.
I know that's what you're saying.
When I was a baby, they said my head was too big and they had to get it checked out. Dead serious. So, someone in the 9th grade when
Yeah.
was born had to be rushed.
Here we go. All righty. All right, so interval notation. Now, what I want you to do is, let's look at an example. Okay? Let's look at just 3 or 4 examples of how we would write inequalities with interval notation. Now, all we're doing is giving ourselves another method of writing inequalities, right? Here's one method we can write an inequality. X is less than or equal to 5. That's an inequality statement, right? What's the graph of it look like? Close circle at 5
going to the left.
and shade to the left. All right. So that's what the set notation, the graphing looks like. Now, here's what interval notation looks like. You ready? X is an element of the interval from negative infinity up to 5, including 5.
That is
All right, so let's just think about this. Do what? It does make sense. All right, now let's go back and talk about the interval notation rules. What are the 3 rules for interval notation? It has to go from smallest value to largest value. Negative infinity is certainly smaller than 5. Right, so we're ordered. My closed circle or my equal symbol gets a bracket. In infinity, since we can't ever equal infinity, it's not a stopping point, it's not a closed circle, gets a parentheses. Okay? So x is an element of the set from negative infinity up to 5. All right, let's look at another example, and then we'll just kind of go into our lesson. And what we're going to do is add this.
If it was like negative 85, would it have a bracket on that side? Or would it still have a parentheses?
I'm confused.
We'll talk about that in a second. I mean, I'll actually show you one like that. No, put your hand down. All right, so x is less than negative 4. X is less than negative 4. No, let's change it. X is greater than negative 4. Because we just did a less than. Let's do a greater than.
Let's do that. Gosh, switch it up.
All right. Now, what would the number line look like?
It would be
Open circle at 4, going to the right.
Open circle at 4 and shade to the right. Right? Now, let's describe that set using interval notation. What's the smallest value in this set? It's negative 4, but negative 4 is not really in the set, right? But it is the ending point. It goes all the way to infinity. All right? And in this case, we need parentheses on both ends. So what this says is x is an element of the interval from negative 4 to infinity, not including negative 4.
That's pretty cool.
All right? Now, let's look at one more, and somebody mentioned a compound inequality. Let's say that x was some value between two things. Let's say negative 5 is less than or equal to x is less than 7. All right? Now, this is all values. Can y'all see what this looks like, right? This is all values between negative 5 and positive 7, including negative 5, but not including 7, positive 7. All right, so the number line would look like this. Negative 5 to 7, close circle at negative 5, open circle at 7, and shade everything in between. The interval, x is an element of smallest value to largest value, bracket, parentheses. Yes.
I don't get like the bracket and parentheses.
I don't either.
The bracket means it's...
I get everything else.
Hey, go back up and read.
Yeah, I don't
Read
get
the
that.
rules you were supposed to write.
Not hurry. Yes. All right. So there was a lot of questions going on. Did y'all resolve your issues?
I got
Not at all.
You got it?
I don't understand the parentheses difference.
Sean, help me.
Equality, look at the rules. There's 3 rules. Smallest value to largest value.
I get that part.
Less than or equal to, greater than or equal to gets a bracket. So we're greater than or equal to, less than or equal to, here x is greater than or equal to negative 5, so that gets a bracket at negative 5. Okay? Less than 7, just less than has to have a parentheses.
It's based on the equal to.
Yeah. So the bracket, the hard bracket shows equality. The parentheses shows that it gets close but never gets there. Yeah, Griffin.
So will the infinity sign always have the parentheses because it would never be?
That's right, because infinity cannot be equaled. It's not a hard stopping point. Okay, we go just like 7 is not a hard stopping point, right? No, it's not. Because we're going to get closer and closer and closer and closer and closer to 7, but never get there. It's infinitesimally close, right? So, 1/1,000,000th close to 7. 1/1,000,000,000th close to 7. Where you just get closer and closer. Any number less than 7 works. How many numbers are there between 6.9 and 7? There's an infinite number of numbers there, right? So that's why that's a soft thing. It never gets there. 7's not a hard stopping point. 5 is a hard stopping point. We go all the way to 5, bam. We stop at 5. We get there. We get there and we stop there. Are we ever going to get to 7? No. You can't. All right. We're not going to spend any more time there because we don't need to. But y'all listen to this. You know how to do that already. But let's talk about graphing these and then stating them in interval notation. So we're kind of adding a little wrinkle to the lesson today. What would the graph of this inequality be?
Open circle on 5.
Open circle at 5 and shade behind. All right, we're talking right or left?
Right, this way.
Right.
This way.
All right, y'all listen to me. No more this way. It's right or left. Okay. All right. Shh. Now, describe this as an interval. Not X. In this case, we're talking about G.
G is an element of
5
in parentheses on both sides.
Yeah. Right? So G is an element of 5 to infinity. Now, the way that this comes into play, guys, a lot, if you open up a calculus textbook, you're going to see this notation written everywhere. Okay? It's something that you're going to have to be able to read and make sense of. And you need to be able to kind of see it graphically, and you need to be able to see it from an inequality standpoint. So what we're really learning when we're learning interval notation is we're learning language, learning how to read a calculus textbook in a few years. Okay. All right. So what about v is greater than or equal to 6? Y'all just wait. Everybody work on it. Shh. Everybody just work on it a second. Close circle 6 and shade to the right. Right? Only if the variable's on the left. Okay? Because this is the same as 6 is less than or equal to v. All right? So we don't always shade the direction of the arrow. It's safe to say that if the variable's on the left, but you can't do it that way.
I think I got it.
All right. Now, what would the interval notation be for this?
B is an element of bracket 6, comma, infinity, parentheses.
Yes. See, it's not difficult. You're just learning to translate graphs into intervals. Now, the advanced statement, just like when you get advanced in a language, like if you're multilingual, you want to be able to have to not interpret it before you speak it. You want to just be able to speak it. So as you get better at this, you would want to be able to go straight from an inequality to the interval notation. But in the meantime, and I tell my college algebra students this too, because they've not seen this a lot. I think we need to emphasize this more in our Algebra 2 and other classes. But it helps if you're confused at all to graph the number line, which everybody's pretty good at, and then do the other thing. All right? So here's your trick question, Cooper. This says 10 is greater than f. Right? Ten is greater than f. Sean, so we know we've got an open circle. Shade to the left. Why? Because 10 is bigger than f. So f is all the things that are littler than 10. That's right. 10 is bigger than F is the same thing as saying F is less than 10. So you got to be really, really careful with how you graph those. Now, the interval notation would be F is an element of parentheses, negative infinity up to 10, and another parentheses. Yeah, I mean, it's like I said, it's not difficult. You just have to learn those rules. Your intervals have to be ordered, smallest to greatest, and equals get brackets, parentheses get. All right. What would the inequality for this graph be? This is working it backwards. Greater than -1. What's the interval notation?
X is an element of parentheses.
Right? So that would be the inequality and the interval notation. All right? Visa, do this one for me. What would the inequality be?
The inequality would be X is greater than or equal to 25.
All right? Interval notation?
Would be
Let's go to Toddy. Interval notation.
X is an element.
Okay?
Bracket. 25.
25.
Infinity.
Infinity. Yeah, good. All right. I don't think we need to do any more of that. Marie does not take a break until she has practiced violin for at least half an hour. Yes, I'm so proud of her.
She's probably garbage at it.
Write an inequality to represent the number of hours that Marie must practice before she takes a break. All right, Liam?
X.
Let's use something that speaks to the situation.
For hours.
Hours or time, right? And it would be okay to use X. I'm just trying to train you to adapt to the situation. Let's communicate. H would be what?
H is at least.
All right, what does that mean?
It's
Greater than or equal to?
30.
Let's say 0.5 or 1/2. The reason we're keeping we're keeping the units as they're given to us. All right, we don't want to change units. Graph the solution set. Now, realistically, would this go forever?
No, because she
No.
died.
I would hope not.
So there's
No, she died.
but we don't have. So let's kind of talk about what the maximum amount of time she could probably. What's the Guinness World Record for playing the violin? I guarantee you there is one.
58 hours and 36 seconds.
Yeah, look it up.
92 hours and 30 seconds.
58 hours,
You think it's-
38 minutes, and 56
You
seconds.
have to eat, so however long.
However long you go without eating, I think.
What? I mean, surely there's a record for that.
I bet the set one
There's a
comes
record
from
forever.
Siri.
Is it like a
Why should be like
without stopping,
Yeah,
like, at all?
without stopping, you can't go more than like.
Okay, it's however long you play without because there could be
All right. Let's. All right, stop. This is taking too long to look up. But what we're going to do this, if we were going to do that, then we would have 0.5 is here somewhere, right? And then our upper limit would be somewhere up here, Do what? Does it say?
33 hours, 2 minutes and 41 seconds.
33 hours approximately. We're going to say that. So this young Marie has not broken the Guinness World Record. So her practice time is going to be somewhere in there. And the reason that I ask you that is because we really wouldn't want to say that that's an infinite set. Because it's impossible for her to play infinite, an infinite amount of time. So if we wanted to express this, as an interval, the amount of time that she practiced would have to be somewhere between 0.5 and 33. Now, we would stop.
Oh my, you were still.
All right. Okay. All right. So your homework is page 317, A through J, 1 through 19, 23 through 30. I am going to adapt the directions. Okay. And I want you to, in addition to doing what the problem says, I want you to express all inequalities in interval notation. All right, so, no. I'm going to answer the question. I want you to do exactly what we just did in all of the example problems. If it says to write the inequality from a graph, I want you to write the inequality, and I also want you to do interval notation. If it says to graph the inequality, then I want you to graph the inequality, and I also want you to do interval notation. Okay, so practice all three formats in every problem. Whatever problem they give, if they give it to you in one format, do the other two. You got a good 15 minutes, so let's grab a textbook and get started.